What do you know about gravity?
9.8 newtons.
Grand. And let's see. Okay, let's give this a go.
Okay. So the acceleration is 9.8 meters per second squared.
Yep.
S is 1.4.
Let's think about this. Okay.
The initial velocity is 0.
Mm-hmm.
And then we can work out it from there. SUA.
Let's see. S. All right, we'll do the start ones. Okay, how about this?
Okay. So you could do v squared equals u squared plus 2as.
I believe it would have to be s equals ut plus a half at squared. We have u, not v.
Oh yeah. Okay. So it'd be 1.4 equals 0. Would it just be 0 plus? Because u, which is 0, u times t is 0, right?
Yeah.
0 plus a half of a, so a half of 9.8 squared.
T
So we do
squared.
9.8. Oh yeah, t squared. So we do 9.8 times a half. Which is 4.9. So it'd be 1.4 equals 4.9 times t squared.
Yep.
Would there not? There wouldn't be anything on the left, like in between. There'd be 0.
Yeah.
Yeah. And then we can minus 1.4 on both sides.
It's one way to do it. Yeah.
Or you can just divide by 4.9 on both sides.
Mm-hmm.
Which is 2 over 7.
Okay.
2 to the 7 equals t squared, and then you square root both sides.
Yep.
And you get square root of 14 over 7.
And so t is square root of 14 over 7.
Yeah.
And you could get it to 3 decimal place or 3 sig fig or something. The thing that I wanted to just kind of point out with this one was usually I would take a as minus 9.8, and then you'd have to take s as minus 1.4 because you're starting up here and you're going there. So if that's 0, then down there would be minus 1.4.
Yeah.
But so long as they're both the same, because it's the same direction, that's the direction of the acceleration of gravity. It's also the direction of motion. And so long as they're the same sign,
Yeah.
it'll work out. So sometimes the signs are different. There's a second part, but it's the same idea. The speed, you just find v.
Yeah.
Yep. How about this one?
So would S be 7?
Later than this feet.
Okay, thanks, Jim. Sorry, S is 7, yeah?
Yeah. And would the speed be initial velocity? Which is 21.
Yeah.
Okay. Okay. So for this, should we use the same equation? S equals ut plus a half at squared. Oh, no, we don't have t, so we can't do it, can we?
And even the S is weird. So it's 7 above the ground. We want to find its greatest height.
Yeah.
So it's like we want to find S.
Okay.
So we know U is 20.
Acceleration's 9.8. Which is, yeah.
Hang on. So if S is the greatest height, then we would have to say A is minus 9.8.
Okay.
And so what would you do here?
So we have the initial velocity and the acceleration.
Okay, we need one more thing.
Is it final velocity,
Yeah.
which is 21?
Which is, that's the initial velocity. At its greatest height, what do you know about its velocity?
Top, isn't it? 0.
Yes, the final velocity will be 0.
Yeah.
And so that's what you would use. Okay, what do we get?
So we use v squared equals u squared plus 2as.
Mm-hmm.
So it'd be v, which is 0 squared, equals 21 squared plus 2 times a, which is minus 9.8 times s.
Yeah.
If you work that out, you get, so 21 squared is 441, so it'd be 0 equals 441 plus, and then 2 times minus 9.8, which is minus 19.6. So 441 minus 19.6, and then s at the end.
Right.
Equals 0. And then you take them away, so 441 minus 19.6 is 421.4 s. And then you can divide by s on both sides. And divide by 421.
Okay. Tell me what you get.
Okay. Zero. Divide 0 by the number, it gives you 0.
Something's gone wrong. Just put it into your calculator, maybe. I think it should be minus 21 squared divided by minus 4.9.
I got 22.5.
I believe I got the same thing. Yeah. Okay. How about B?
Okay. So now we have S is 22.5, right?
S I think this was 22.5, and it is 7 meters above the ground. So we want to know the height above the ground that it reached. Any idea about that?
You add them together.
Yep.
So it'd be 29.5.
So that's 29.5. Yep.
And then we
29
got
meters.
U, V, and A.
So B. So let's see. The time of flight of the ball. All right. What are the values?
So we have 29.5, and then U is 21, V is 0, A is minus 9.8.
And so let's just take a look. So you have the ball here.
Yeah.
You project it up to its highest point, and then it falls back down.
Yeah.
Up here, V is 0. Down here,
Yeah.
U is 21. And so if you do U is 21, V is 0, how much of the journey do you get?
0.
No. How much of the journey is it from the bottom to the top?
Half the journey.
Yes. And so what would you have to do with your answer to this one?
Double it.
Double it. There is another way you can do it. Do you know what speed the ball will be traveling at the bottom when it passes, like at the end of the journey?
0.
No, it's 0 at the top. Any idea?
Oh, it's 21.
So it's 21 on the way up, and so on the way down?
Minus 21.
Correct. And so you can say U is 21, and you can say V is minus 21, and that way you'll get the whole journey all in one go. We said we want T, and so what other thing do we have?
We have the acceleration and
Well,
the height.
We have the acceleration.
Yeah.
But we don't have the height, because this height of half of the journey is 21. See what I mean?
Yeah.
And so we'd have to double that. You might as well double time if you're going to do that. The easiest thing is when you're going like this, use acceleration, because that's always going to be the same.
Yeah.
All right, what's this one going to be?
Okay. V equals U plus AT,
Yeah.
which would become minus 21 equals 21 add minus 9.8 T. And then you can minus 21 on both sides,
Sure. I'm just going.
which gives you 42, sorry. Minus 42 equals minus 9.8 T. Then you divide by 9.8, minus 9.8 on both sides. Which gives you 30 over 7 equals T.
Okay, 30 over 7, and I got that. I think it's the same thing. Just by putting in the calculator. I just want to see something. Calculator. So I got that. Let me blank it. Answer. And it gives me 30 over 7 as well. So just in case you need an exact value. In case it's a difficult equation to solve. If there's only one answer, you don't need to worry about it too much.
Yeah.
That's it. Okay, grand. So hang on. So big picture is the direction of motion. U is 21, and so acceleration is minus 9.8. And I would just take up to be positive, almost all the time. Yeah. And when something comes back around to where it was, if it's constant acceleration, then it will just be the negative of the other velocity at that point.
Yeah.
And that way you don't have to double the time and all of that. All right, let's try this one.
Okay. So I got the height as 62.5. Is that right? So S.
So S is 62.5.
And then V is 0 and A is minus 9.8.
So A is minus 9.8 is good. V is 0, and you have to find U.
Okay. So we have S, A, and V. So could we use V squared equals E squared plus 2AS?
Yep.
0 squared equals U squared plus 2 times minus 9.8 times 62.5. Work it out. I got minus 1,225.
Okay.
So it'd be 0 equals U squared plus or minus 1,225. And then you can add 1,225 on both sides, which gives you 1,225 equals U squared. Then you square root both sides, which is 35 equals U.
Yeah, and so U is 35 meters per second. The reason why I didn't put this into my calculator is because if the unknown is squared, then you can get two answers. So my calculator might have said minus 35 because it only gets one answer. It only gives the first answer if you use that solve method. Whereas at this, you know, we know that it means positive 35. But if the calculator said minus 35, you might just think, you know, you might just write down minus because the calculator said it.
Yeah.
And B, I think we needed that for part B.
Okay. Okay, so we need the initial velocity, which is the initial velocity would be what we got as the answer, which is 35.
Okay.
The final velocity will be minus 35.
Okay.
As S 62.5 minus 50.
So it would look like this, like shoots up, shoots down. This here is like the 50 mark. This here is the 62.5 mark.
Yep.
We want the time that it's above 50. Any idea what we do there?
So first would we work out 50, like up to 50, then take away the final answer from the one we worked out before.
And so what are your things here?
So would S be 50?
So S is 50.
And A is minus 9.8.
Yeah, it's a good one.
And we're working out T.
Oh yeah, we're working out T, so we don't need A.
Okay. U B.
Hang on. Alright, go on.
S equals U plus V over 2T. So it'd become 50 equals 35 plus minus 35 over 2, and then t on the outside, so it'd just be 0 over 2, and then it would just become 0t, which is 0, so 50 equals 0.
Yeah, that's not right. This didn't look good. So we can't use, let's change v equals minus 35 into a equals minus 9.8.
Okay. US. So we can use s equals ut plus a half at squared. So it'd be 50 equals u, which is 35t, plus a half brackets a, which is minus 9.8, close brackets t squared.
Yeah, I just kind of remember it's minus 4.9. Comes up a lot.
Yeah. And then you can do a half times minus 9.8, which is 4.9, minus 4.9. So it'd be 50 equals 35t minus 4.9 t squared.
Right.
And then you can minus 50 on both sides.
Yep.
Which gives you minus 4.9 t squared add 35t minus 50.
Mm-hmm.
And then you can work that as a quadratic.
Go on.
Okay. I got so t can be 25 plus 5 root 5 over 7, or the other one, which is minus, so it'd be t equals 25 minus 5 root 5 over 7.
Over 7. Okay, so we want the total time.
No, it said 25 plus or minus 5 root 5, and then over 7.
Just the what part is over 7?
All of it.
Okay. Over 7. And so okay, how do we get the total time that is above that?
We do our last answer minus the new answer we've got.
Yeah.
Which is would it be 35? No, yeah. Wait, no.
What do you mean our last answer plus our new answer?
The one we got for part. I don't know. Oh, 62.5.
Nope. So let's check something. So 25. Let me do the fraction first.
Wouldn't it be t for the last answer? So for A, if we worked out t for like question A, and then we took it away from this answer we've got now.
Now,
isn't that the answer?
So what we found was this is roughly 5 seconds. 5.17 seconds. It reaches here, so down here it's like 0 seconds. Goes up, and then if we change that to the negative, that is one. Okay, so 1.97. So it's it's another way around. 1.97. Oops. 1.97 seconds. So let's say it's shot from this side. So 1.97 seconds later, it has a height of 50, s equals 50, and then it goes up, comes back down, and 5.17 seconds after it's the start, it is at 50 again. So we want the total time that it's 50 or more.
So from 0 to 50, it's 1.97 seconds.
Yeah.
So you do 5.17 minus 1.97.
Correct. It's the difference between these two.
Okay. Which is 3.2.
3.20 is it?
Yeah, 3.20.
Alright, so time is 3.20 seconds. Now I just rounded that. Hope you're not rounded stuff. That's A, and then B, 3.2 seconds. Yeah. And so that's how this works. That's why I was expecting to get 2 times. Like when is time 50? Sorry, when is S 50? And there are 2 different times, and you find the difference between them.
Yeah.
All right. Unless you have questions, let me see this one. Upwards with a speed. Okay. Oh, this is getting to be pure algebra. It returns to O. All right. Let's try that. Can you hear me?
I can hear you now.
Okay.
Yeah.
Don't know what happened. Let me just do that. Yep. Okay, so we're getting into pure algebra. How about this one?
Okay. So I got initial velocity is 0 and acceleration is minus 9.8.
Initial velocity is u.
Okay.
A is minus 9.8. And what was the third thing?
Would that be time?
So time is what?
2 seconds.
Time is 2. And so we want the value of u. So we have u equals u.
Mm-hmm.
We need a fourth thing.
Would final velocity be a third u?
Yep. Let's give that a go.
Okay. So do we want one of the equations that has both u and v in them, or just one of them?
We need an equation that has all 4 of these.
All 4. So s equals u plus v over a half t.
That doesn't.
Wait, no, doesn't have a.
Yeah. We need one.
So v equals u plus at.
Yeah. V equals
So
u plus at.
a third u equals u plus minus brackets minus 9.8 times 2, which give you a third u equals u minus 19.6.
Yep.
And then could you minus u on both sides?
Yeah.
So would that give you a third u minus u?
Yep.
Equals minus 19.6. And then can you times by a third on both sides?
What is a third u minus u?
Minus a third u.
Put into calculator a third minus 1.
Minus 2/3.
Yep.
So it's minus 2/3 u.
Minus 2/3 u.
Equals minus 19.6. And then can you times by minus a third on both 2/3 on both sides?
Divide both sides by minus 2/3.
Okay. Which gives you 29.4. So u equals 29.4.
Yep. So all the way back here, a third u equals u minus 9.8 times 2. I just put in a third x equals x minus 9.8 times 2.
Yeah.
Shift solve 7. Yeah, let's just calculator it. If there's only going to be one answer, it's calculator. Okay, and B.
Okay. So initial velocity would be 29.4 and final velocity would be minus 29.4.
Great.
And then would you need A as well?
Yep.
Minus 9.8. And then we can work out from there, can't we?
And so T is T. Yeah, give that a go. Put that in calculator. What one are you doing?
V equals U plus AT.
Yep.
Put that on the calculator. So it'd be minus 29.4 equals 29.4 plus A, which is minus 9.8. And then X.
Mm-hmm.
I got X as 6.
And so time is 6. Let's take a look. That was 29.4. And then this one. And where is it? Down the bottom, 6 seconds. Okay, I like that way much more.
Yeah.
Alright, a ball is released from rest at a point 10 above. Each time the ball strikes the floor, it rebounds with 3/4 of the speed. Alright, how do we do this?
So initial velocity is 0.
Yep.
S is 10. A is minus 9.8.
Either they're both positive or they're both negative.
So S is just 9.8 then.
So A is 9.8, S is 10. And we want the first time it rebounds from the floor. What does that mean? It rebounds the first time it rebounds from the floor? Hopefully it's just T is T, is that right? Hang on,
Maybe.
I need to check that. U is 0, A is that. V. What is this? Oh, find the greatest height. Ah, okay. Okay, so basically, you have the ball, you drop it, hits the ground. So this is 10 up, and you want the height that it reaches after it bounces off the ground. Done. Yeah, so you want this height, basically.
Okay.
Okay, how do we do this?
So we want T, right?
Oh, I don't know, but maybe probably wouldn't be bad to get it.
Yeah.
Let me think. So what would we need to get this height?
Well, we need the final velocity.
Okay, what would final velocity be? What do you mean final velocity for which part of the journey?
When it hits the ground.
Yeah, that's what we need.
So we need to work that out first.
Mm-hmm.
So we could use v squared equals u squared plus 2as.
Mm-hmm.
V squared equals. So it'd be v squared equals 0 squared plus 2 times 9.8 times 10. And then you work it out, so you get you'd get v squared equals 19.7.
Mm-hmm.
Would it be 196? V squared equals 196.
Okay.
And then you square root both sides. So v is 14.
Okay. So what's next?
So now we have S, U, V, and A. We don't need A anymore, do we? We only need S, U, and V.
Okay, so what?
So we could use S equals U plus V over 2T. So it'd be 10 equals 0
No.
plus...
So now this different journey. What do you know about this different journey? So we said...
Okay, so initial velocity is now 14.
Yeah, so now for that journey, initial velocity is 14.
Final velocity will be 0.
Well done.
T is T. A is 9.8.
So A is minus 9.8. But we want the greatest height it reaches. So we want...
So is it just 9.8?
No, the height?
10.
No, like this height?
A.
Yeah, how do we get that?
So we use the equation.
Alright, which one?
So we get V squared equals U squared plus 2AS.
Well done. Yeah, so they said, you know, the first time, but what they're really talking about is the first time it bounces. So it's actually the height we have to find. Yeah, S. Okay, V squared is U squared plus 2AS. And S isn't squared, so that'll just be one answer. And so I'm using calculator. Wait, hold on. We didn't account for something. So I just did that and I got 10. It can't bounce back up to 10. That's because it told us each time the ball strikes the floor, it rebounds with 3/4 of its speed. So what would that change?
Would that change the initial velocity?
Yeah.
So you times it by a third.
3/4.
Yeah. 3/4. Which is 10.5.
Okay. And so yeah, change U to 10.5.
Okay. I got X as 5.625, I believe.
Yep. Great. And I'll just press answer equals 45/8. It's good.
Yep.
Okay, second time it bounces.
Okay, so So S would be, we want to work out the final velocity for this.
Yeah.
That'll be the initial velocity to work out the second time it bounces.
Yeah.
So we got S is 5.625.
Yeah.
A is 9.8.
Well done.
And initial velocity is 0.
Yeah.
Let me work out from there.
Yeah. So similar to what we did. Let me see this one. Boy. Oh, I can't even find it. Probably quicker to just work it out. So v squared. So hopefully I'll just get a positive answer. U squared is 0 squared plus 2. Wait, 2 9.8 and S was 5.625. So we get 10.5.
Okay.
So that's V. What do we do with that?
Okay, so S. I mean, put that as, now it's U. 10.5 is now U.
It's our U. We thought it was 14 the last time, but what was it actually?
Oh, it was 3/4.
Yeah.
So we times it by. Okay. Which is 7.875.
Mm-hmm.
And then V is 0.
Yeah.
A is minus 9.8.
Mm-hmm.
And we want S, right? So S is S.
Mm-hmm. Let's try that.
Okay. So we use V squared equals U squared plus 2AS. So V0 squared equals 7.875 squared plus 2 times minus 9.8 times S. Put that on the calculator. I got 3.16 to 2 decimal places.
Is it 1/6 recurring or something?
Pardon?
I will see. Okay, and that they rounded it to 3.2 to 2 sig fig. Great.
Yeah.
Yeah. So this is a tricky one, but quite common. The question before this, like this is U, and then this is a third of U. It's similar to this one is V, and that becomes the new U is 3/4 of that V. And yeah, you have to do it twice, and so it slowly, like it bounces, doesn't get as high, bounces again, doesn't get as high. Grand. Okay. There was only one more type that I wanted to do. Let me see from rest at the same time. Oh, this is a weird one. Yeah, it's weird, but let me just see something. Yeah. All right. Let me see. Right, let's give this a go.
Okay. So for this we need two Savart equations.
Yeah.
Okay. So one for ball A and one for ball B.
Mm-hmm.
Okay, so for ball A you'd have at rest, so it'd be initial velocity is 0, S is 63, and A is minus 9, or just 9.8.
So U is 0. A is 9.8. Let me see, a ball, so it's kind of weird though. The distance, this is weird. So let's say this is 63. And let's say they collide here.
Yeah.
If they collide here, oh, how would we phrase this? So this, if we called this distance S, then what would you call the other distance?
Don't know.
You'd have to call it, well, they have to add up to 63. This plus this makes 63.
So S plus S.
Sorry?
So S plus S.
This would be, well, let's call it X. So let's say X plus S is equal to 63. Make X the subject, what do you get?
X equals 63 minus S.
So this will call 63 minus S. And so they will add up to 63. So for ball A, we have U, we have A, we have S. How about ball B?
We have initial velocity is 21.
So U is 21.
Yep. Would wait. S be 0?
That would just give you that, like, that'll be like the end of its journey would be at 0.
Oh.
So S for ball 2?
Oh, would it be 63 minus S?
Yeah, that would be 63 minus S. We need one more thing.
9.8.
So A. So you need to be careful about this. Would they both be positive A's? Both negative? 1 minus 1 plus? Let me see. So we're saying that this S, yeah, so that'll be a positive one. And then this 63 minus, I think this will be minus 9.8.
Yeah.
There is, so what other thing will both balls have in common when they hit into each other?
They have the same acceleration.
All right, we have acceleration already. Anything else we
They
don't
both have the same force. Like weight.
Nope. Suvat. We need one more thing for Suvat.
We need the final velocity.
They'll have different final velocities
Okay.
in the same way they have different initial velocities.
Wait, but can't we do the equation with just what we've got now? Or would that not work?
No, that's only three things.
Oh, we need t equals t.
Yes, we need t because the t of one will be the same as the t of the other.
Yeah.
We'll be able to swap that in. And so, all right, what can we do?
Okay. You can use s equals ut plus a half at squared.
Yep.
So it'd be, for a it would be s equals u, which is 0, or yeah, just 0 plus a half brackets 9.8 and then t squared.
Yep.
And then it's equal to, would you make it equal to each other, the equations?
Yes. So what will be second equation?
It would be s, no, 63 minus s equals u, which is 21 t plus a half brackets minus 9.8 t squared.
Yeah.
You make them equal to each other.
Well done. So this s equals this. So this thing here, sub that there. 63 minus a half 9.8 t squared is equal to 21t minus 4.9 t squared. You would solve that and you would take the first answer when they initially hit into each other.
Yeah.
Yes, so this is simultaneous equations. The other thing is, this is difficult with the s and 63 minus s. An important thing is you can swap between the two because the t's will be the same.
Yeah.
Different initial velocity, different final velocity, different distance, different acceleration, but the same time. And that's a useful thing.
Yeah.
And so that stuff, what do you give yourself?
Probably a tick. Okay.
All right, well, we finished that chapter anyway. I think we've got 2 more to go. How was that for you, Adam?
That was good.
Any questions for me in general?
No.
All right, well done. You did great. I look forward to trying again next time.